grade 12 matriculants. We are still looking at proportionality, and on this one we want to look at ratios, multiple ratios on a single line. Let's try and see if we can do this one as quickly as possible. I hope it's going to be short. We have AB as to BC being equal to 3 as to 2. This is our AB as to BC. So this is 3 as to 2. And then BC as to CD. BC as to CD. This is 6 as to 5. These two ratios are on the single line. They are on the same line. So to identify, for identification purposes, we need to include these variables. Let these be y. So we have these ones on top as x, these ones below as y. Now, answering the question there, we have AB as to BC. Our ratio there, your AB is 3x as to your CD, not BC, it's CD is 5y. And then we cannot take this as the ratio because we have an x, we have a y there. We need to first get rid of those things. How do we do that? We make use of what we have here. Your BC here is equal to 2x and it's also equal to 6y. Right? Now, this is the relationship between x and y. We can get the value of x here by dividing both sides by 2 to get 6 divided by 2 there is 3. So x is equal to 3y. Where we have an x, we can replace it with 3y. So we have 3 bracket 3y as to 5y. So this is 3 by 3. It's a 9y as to 5y. Divide both sides by y, we have 9 as to 5. That is the ratio there. Let's look at this one. We have PQ as to QS given, QR as to RS given. PQ there is a 2, but let's write it with a variable there. This is 2x, and then QS, this is your QS there is a 3, so let it be 3x. And then we have QR. Our QR is here, let it be 5y. And then RS, this is 3y. So we have our ratios there. This I want to write it as QR as to PQ. So where is my QR? This is my QR there. It's 5y as to PQ. This is my PQ is 2x. There we are. Now we also have to get rid of this x and the y. Let's use QS here. We can see from the diagram that QS is equal to 3x there. It's also equal to this 3x is equal to 5 plus 3 there. That is 8y. So from these two, we can divide both sides by 3 to get x is equal to 8y over 3. So where we have an x, we are replacing it with this one. So come here, there is our x there. So I have 5y as to 2 multiplied by 8y over 3. This simplifies to 5y as to 16y over 3. Alright, what do we do with this 3? We can take this 3 to the other side, and then we are going to have 3 by 5 is 15y as to 16y. So QR as to PQ is 15 as to 16 if you divide both sides by y here. So we have 15 over 16, that is the ratio there. Let's look at another one. We have two of them here. We have AB as to BD. Your AB there is 3. Let's write it as 3x as to BD. That is this long one. Is it BD? Oh no, it's BC. It's BC here. So it's 2. We have 2x here. And then AC, that is AC there we are. AC is 10y. S2 CD, this is 3y. So we have AB being 3x and then BC being 2x. Now we need to determine AB as to BD. AB as to BD. Your AB there is 3x. As to BD, we have our BD here. BD is made up of BC plus CD, that is 3x plus 3y. 2x plus 3y. But now, in this ratio, we have two variables and we need to get rid of those two variables. Let's make use of AC here. Our AC is telling us that 3x plus 3x plus 2x plus 2x there is supposed to be equal to 10y there. This is 5. X is equal to 10y. So your x there is equal to divide both sides by 2. We have divide both sides by 5. We have 2y. So we come back here, replace this with a y. We come here, it said x, we are replacing this x and this x. So we have 3 multiplied by 2y S2 2 multiplied by 2y plus 3y. So what we have done here, x is equal to 2y. So where we have x here, we are replacing it with 2y. So the ratio there is going to be, this is 6y S2. This here is a 4 and a 3. So 4 plus 3, 7y. And then divide both sides by y, you are left with 6 to 7. So the ratio there is 6 to 7. And then for the second one, let's look at the second one there. This one we are given that KL S to LN. This is 3x, this is KL, and then we have LN. LN is 13x there, and then the second one km, this is km is 5y S2 mn, so this is 3y. So we have our two ratios there, the one on top with an x, the one below with a y. The question is saying determine the ratio KL S2 LM. I'll write it this way, KL S2 LM. KL there is 3x, S2 LM. We don't have anything for the LM here. We do have this whole KM, we have this. So we can say LM is equal to KM minus KL. So this is 5y minus 3x. That is our LM there. So let's write it there. 5y minus 3x. That is our ratio. You could also use ln there. Your ln is equal to 13, and then we have this. So we can say 13x minus 3y. Your lm can also be written as 13x minus 3y. All right. Now, we need the relationship that's going to help us to eliminate the variables here. For this one, we need to use the whole line. We need to use the whole line. Let me remove this. Using the whole line, you'll see that on top it's 3x plus 13x. That is equal to, using what is down here, it's 5y plus 3y. 13, that is a 16x, is equal to, this is 8y. To get the value of y here, let's divide by 8, so your y there is equal to 2x. Come back here, replace the y with a 2x. Here is my y here, so this is 3x, and we have a 5 multiplied by 2x minus 3, close the bracket there, x. So your 3x here is s2, this is 10 minus 3, 7x. So the ratio there will be 3 over 7. So we are saying here your y is equal to 2x. Let's use that other method, getting it from ln. We said this lm can be written as this whole line minus this line, that is 13x minus 3y. So we are saying this ratio can also be written as 3x. As 2, we are now using this 13x minus 3y. 13x minus 3y. And here we said y is equal to 2x. So we are putting 2x here. So this is 3x as 2, 13x minus 3 by 2x. So this is a 6 here. So this is 3x as 2, 13 minus 3 times 2 is a 6. 13 minus 6 is 7x. So you see it also gives you the same ratio, 3 over 7. Let's go to the last one there. The last one here we have PA as to AQ. On our diagram, PA as to AQ, we have 2 as to 5. Another ratio there, BC as to CR. This is our BC, that is a 4 as to CR, that is a 9. I did not write them in variables because they are not on the same line there. But to be safe, just write them with variables. 4y, 9y, 5x, and 2x. Now, we have CB as to CR. This is your CB as to CR. Not CB, hey, I'm making a mistake there. It's QB as to CR. We do not have anything here, but we can get it from this side using our proportionality theorem there. Our proportionality theorem says QA over AP is equal to QB over BC, and this is equal to QA, it's 5x over 2x, and raising probe theorem because AB is parallel to PC. So we can now write this. This is 5x and this is 2x. So we now have our ratios on the same line there. We can answer the question now. QB as to CR. Your QB there is 5x. As to your CR there is 9y. But we have different variables here. We need to get rid of them. We are using this one, BC, making use of BC. 2x is equal to 4y because they are on the same line. So it's 2x is equal to 4y. Divide both sides by 2. We have that x is equal to 4 divided by 2. So it's 2y. Go back there where we have an x, we're putting 2y. There we are. So this is 5, 2y there as to 9y. This is 10y as to 9y. Divide both sides by y. We have that the ratio is 10 as to 9. And then the last one there, let me get rid of this. We have CR as to QC. There is my CR. CR S2 QC there should be equal to CR is 9Y, QC there, QC there we can add 5x and 2x to get 7x. But that's not our ratio because we have these different variables. We need to get rid of those ones. We saw that from here that your x is equal to 2y. So in place of x, we are writing 2y. There we are. So this is 9y S2, 7 by 2y. So it's 9y S2, 14y. Therefore, your 9 S2, 14. That is our ratio. This is equal to 9 S2, 14. All right, that's all I have for you now. Full stop.